As the plan stands today, the next mission you would see launch is Artemis 3, which would attempt a crewed landing on the moon in 2028. Launching a lunar rocket every 3 years is not a strategy consistent with success. We are learning the same lessons because skills atrophy without repetition. In fact, across all NASA programs, from Mercury through Space Shuttle, this is by far the lowest launch cadence in the history of America's space program. The plan is not evolutionary in design, but instead reaches for a fully realized end state without building the foundation required to achieve it. In alignment with President Trump's national space policy and making the absolute most of the resources provided under President Trump's Working Family Tax Cut Act, along with the funding and support of Congress, we are altering the plan and bringing extreme focus to this grand endeavor. I'm pleased to announce the following. We will standardize the remaining SLS rockets to a near Block 1 configuration. We will strengthen our workforce and rebuild our core competencies in ground systems and stacking operations, bringing down pad turnaround times, and accelerate our launch cadence from every 3 years to every 10 months. We will pull in Artemis 3 and launch in 2027 with the aim to rendezvous with one or both lunar lander providers in low Earth orbit, gaining confidence in lander and XEVA suit systems. We will then prepare for up to 2 lunar landing missions in 2028. In the 1960s, NASA achieved the near impossible in an evolutionary way. We flew Mercury, Gemini, and many Apollo missions before landing on the moon. While we have learned much since then, with enhanced capabilities supported by the best industry partners imaginable, we cannot always jump straight to the desired end state. We need less needless complexity, less distraction, more launches, more operational muscle memory, and extreme focus on the mission. We gladly accept the challenge of returning NASA astronauts to the moon after more than a half century, and this time, to build a moon base to stay. This is the NASA that once changed the world. This is the NASA that will do it again.
Hey, I'm Lucas. Welcome to the SpaceX community. Let's get started.
As engineers continue working through issues with the Space Launch System rocket ahead of Artemis 2, NASA has quietly and now officially reshaped the roadmap for how humans will return to the lunar surface. What was once a fairly straightforward progression from Artemis 1 to Artemis 3 has now turned into something much more complicated, and in my opinion, much more revealing. Over the past few days, NASA Administrator Jared Isaacman announced a major restructuring of the Artemis architecture. Artemis 3, which for years has been marketed as the mission that would land astronauts back on the moon for the first time since Apollo, is no longer that mission. Instead, Artemis 3 is now being redesigned into an Earth orbit rendezvous demonstration between Orion and one or more human landing system vehicles. The actual first lunar landing of the Artemis era is being pushed to Artemis 4, currently targeted for 2028. Artemis 5 could potentially follow later that same year with a second landing attempt. I think that is actually a significant shift. To understand just how big of a change this is, you have to look back at how Artemis was originally structured. The plan was simple on paper. Artemis 1 would send an uncrewed Orion capsule around the moon and return safely to Earth. Artemis 2 would carry astronauts on a similar free return trajectory. Then Artemis 3 would land astronauts near the lunar South Pole using a commercially built human landing system. Now, that third step has effectively been downgraded into a proving ground mission in low Earth orbit. NASA says this simplification reduces mission risk. A recent report from the Aerospace Safety Advisory Panel raised serious concerns about the readiness of the human landing systems and the complexity layered into Artemis 3. The original plan required Orion to rendezvous with a lander in lunar orbit, transfer crew, descend to the surface, ascend back to lunar orbit, and return home, all on a first try with brand new hardware. That's a tall order. Under the revised plan, Artemis 3 will instead focus on demonstrating cryogenic propellant transfer, docking procedures, and systems integration in Earth orbit. In other words, before trusting these vehicles to perform 240,000 miles away, NASA wants to validate them much closer to home. On paper, that sounds reasonable. It buys time for lander development, it lowers risk, it gives NASA more flexibility, but it also highlights how far behind schedule the overall program has drifted. For Artemis 3 and Artemis 4, NASA selected SpaceX to provide the human landing system variant of Starship. That vehicle has flown multiple test missions over the past few years, gathering data on re-entry heating, engine relights, orbital operations, and controlled splashdowns. But critical milestones still remain. In-space cryogenic propellant transfer at scale has not yet been demonstrated operationally, and uncrewed lunar landing and ascent have not occurred. Docking procedures between Orion and Starship HLS remain to be proven in space. Meanwhile, for Artemis 5, NASA selected Blue Origin and its Blue Moon lander. A Pathfinder version known as Mark 1 is undergoing testing at NASA Johnson Space Center, but that vehicle is also not yet flight proven. Before either of these landers can carry astronauts to the surface, they must show the ability to store and transfer supercold propellants in space, dock with Orion, land on the moon autonomously, and return safely to lunar orbit. That is not trivial. So, Artemis 3 becomes a stepping stone instead of the grand return to the moon. At the same time, NASA is also making structural changes to the Space Launch System itself. Originally, Artemis 4 was supposed to debut SLS Block 1B with the more powerful Exploration Upper Stage replacing the interim cryogenic propulsion stage. Now NASA officials say they intend to standardize the SLS configuration to streamline manufacturing and accelerate launch. Cadence. This is where things get even more interesting. Historically, SLS has launched or been scheduled to launch roughly once every 3 years. Artemis 1 flew in late 2022. Artemis 2 is currently targeting an April window, though that is dependent on resolving technical issues. Under the new plan, NASA hopes to reduce the launch cadence to roughly once every 10 months. To accomplish that, NASA says it will rebuild internal core competencies, increase workforce strength, and standardize production flows. In theory, that sounds like a move toward operational maturity, increase production rate, shorten turnaround, normalize hardware. But here's where I need to be honest with you. In my opinion, SLS is already costing far too much money to NASA and to taxpayers. We're talking about a rocket that costs billions per launch. Even if cadence increases, each individual vehicle remains extraordinarily expensive, and speeding up production does not suddenly transform an expendable, shuttle-derived architecture into something modern and sustainable. I genuinely think that instead of trying to increase launch cadence or slightly streamline production, NASA should complete dumb the design and move towards something entirely new. If the agency does not want to outsource every Artemis mission to private companies, and if there are philosophical or political reasons for keeping a government-owned heavy lift capability, then fine. Build your own reusable rocket. Develop something designed from the ground up for rapid reuse and operational efficiency. Would that be difficult? Absolutely. Would it be politically messy? Definitely. But in the long run, it would still be wiser than pouring more billions into what is fundamentally an old-era expendable rocket. Let me hear from you all too. Do you think increasing SLS launch cadence to once every 10 months is the right move? Or do you think NASA should pivot entirely toward a new reusable government rocket, or even fully embrace private heavy lift systems? If you agree with me that pouring more billions into SLS doesn't make long-term sense, comment agree below. And if you disagree, tell me why. I genuinely want to hear your perspective on whether accelerating SLS production is a smart strategy or just doubling down on old design. SLS is powerful. There's no denying that. It uses Heritage shuttle components, solid rocket boosters, and cryogenic propulsion technology that traces its lineage back decades. But Heritage does not equal sustainability. Increasing cadence from once every 3 years to once every 10 months doesn't fix the underlying economic inefficiency. And if the ultimate goal of Artemis is sustained lunar presence, cislunar infrastructure, and eventual Mars missions, then you need launch systems that can fly frequently and cheaply. Administrator Isaacman compared this moment to the Apollo era, pointing out that the United States did not jump straight to Apollo 11. There were Mercury missions, Gemini missions, multiple Apollo tests, flights with relatively rapid cadence, launches every few months. That rhythm built experience and confidence, but the difference is that Apollo hardware was not designed with 21st century industrial expectations. Today, we know how to build reusable systems. We know that rapid cadence drives down cost per flight. We know that iteration and refurbishment can outperform pure expendability. If we're invoking Apollo as inspiration, we should also be willing to modernize beyond it. Meanwhile, engineers at Kennedy Space Center are focused on getting Artemis 2 ready to fly. The SLS rocket was recently rolled back from Launch Complex 39B to the vehicle assembly building after a helium pressurization issue was detected on the interim cryogenic propulsion stage during a wet dress rehearsal. This was the second wet dress rehearsal attempt. Earlier in the month, teams dealt with liquid hydrogen leaks and an early countdown termination. After the more recent test, engineers traced the helium flow problem to a suspected component that must now be removed and examined in detail inside the VAB. Lori Glaze, Acting Associate Administrator for NASA's Exploration Systems Development Mission Directorate, said the component will undergo detailed inspection to identify the root cause. Teams also plan to assess operational procedures to prevent recurrence when the vehicle rolls back out to the pad. If the issue is resolved quickly, Artemis 2 could still target the April 1st launch window with backup opportunities April 3rd through 6th and again April 30th. So, what I don't think makes sense is continuing to spend more and more billions extending the life of an expendable rocket whose economics were questionable from the start. Maybe that sounds harsh, but Artemis is supposed to be about sustainability. It's supposed to establish a long-term presence on the moon. It's supposed to lay groundwork for Mars. You cannot build sustainability on top of an architecture that struggles to fly once per year and costs extraordinary amounts per mission.
Thanks for watching today's episode. Don't forget to subscribe and give us a thumbs up if you enjoyed it. Stay tuned for another great video tomorrow.